We start our session with eminent personality Dr. Randhir Parmar sir. Sir is a polymer chemist and coating technologist currently serving as Chief Senior Manager Technology at the Asian Paints Research and Technology Center. He holds a master's degree in industrial polymer chemistry and PhD in waterborne epoxies and acrylic dispersions for coating from Sardar Patel University, Gujarat. With rich experience in both academia and industry, he has published more than 25 research papers and contributed to 14 patents in paints and coating. His expertise spans waterborne polymers, anti-corrosive and high-performance coatings, UV curable systems, and sustainable coating technologies. He served as lecturer at Institute of Science and Technology for Advanced Studies and Research ISTAR. He is a life member of Paint and Coating Technology Association PAT India, member of Oil Technologies Association OTA India, member of American Chemical Society ACS, and life member of Indian Society for Radiation and Photochemical Sciences. Now, as a part of token of love and respect, now we present a bouquet of flower to Dr. Randhir Parmar sir. I would like to invite Dr. Rohit Dave sir to present bouquet of flower. Thank you, sir. We welcome Dr. Randhir Parmar sir on stage. Now the floor is yours, sir.
Very good morning once again, and welcome to this session on chemical sciences. It's chemical science, right? So the topic here is sustainability, the global trend transforming chemical industry. So we'll begin with the term sustainability. In next how much time? One and a half hour. Okay, we'll try to cover the area of sustainability and how the chemical industries are performing, how they are practicing sustainability, what are the yardsticks of sustainability, and we'll also discuss few examples from molecule, right? It's not there. And then on the name of that, because of ignorance of the customer end, you are trying to kind of push your concept. That is not true. So ideally, true green. So then there are various shades of green. Somebody say, okay, chlorine-free cosmetic shampoo, or maybe no alkaline soap, or maybe green cosmetics, some kind of fragrance, or low VOC fragrance, etc. So those are the kind of claims people make. But if you see the process of designing that particular product or making this particular product, actually there may be many other non-green aspects also. But those non-green aspects nobody highlights, saying that okay, this is green, but there are many other non-greens. So then the debate continued that okay, suppose if you want to assess what is right green, so then there are a lot of shades of green, right? Then somebody said my green is better than yours, mera wala green, your green, like that. There will be kind of debate always. So then how do we assess and how do we judge what is right green or what is right sustainable? So then later all these specifications, standards, yardsticks, all those got developed, right? And now you will find a lot of eco labels which are like authentic, and whosoever wants to make a claim, they have to kind of validate that claim against those specifications, and then only they can put on their container, and then they can advertise it, right? So for us it is also very important to understand that what is right definition of green, what is right definition of sustainability, what are those yardstick where we can measure the particular sustainable or green. Okay, so that's very important. Yeah, so this is what the flow will begin next. So if you see current global market trend, and I believe we are all chemical science community here, and this particular slide is giving us happy vibes, right, to us, because it shows the kind of growth in chemical industry. And you can see like globally the industry is growing at average 3% kind of annual growth, and the growth, the total market size is 5.33 trillion, that is last year 2025, and this year will be 5.686 trillion, right? Very high growth, and particularly the region like Asia, the growth is much higher because of very population of China, India, and all those countries, right? Our own captive consumption is so high, right? You can see sectors like paint and coating, the second part where sectors are mentioned, right? Basic chemicals, agrochemicals, paint, coating, soaps, detergent. I come from paint coating industry, so you can see like it is more than the average 3.5% growth, right? And that's how kind of opportunities are also there. So chemical industry, particularly in India, when it comes to India, the current growth rate and the forecast is 10.9%. And the reason is that we have domestic demand so much, and second is the government support is also there. And nowadays, if you see in all sectors, government is trying to facilitate Make in India, right? Make in India, make it for the world. Now there is another proverb also: Make in India and make it for the world. So that means also promoting the export from here. In fact, these days we are also working closely with government institutions like railways, defense, etc. And the approach is totally different now. Yeah. So there are kind of cooperative spirit we can see, and people who like to really do something together. So that's what it is, right? Now, next one. So the growth is there, but growth is coming with some challenges also, correct? So what are the global challenges that the chemical industry is facing as of now today? So the first one is high energy prices, because the demand is more, you want to produce more, and for high production you need kind of infrastructure, resources, and also the energy is most important resources. Of course, people is also very important resource, and that's the opportunity for all of us actually as a community. So high energy prices, and there's an energy intensive industry. The chemical industry is highly susceptible to oil and gas price volatility, because the source of the raw material is also the oil and gas, and also the energy which is supplied is also based on oil and gas. Right now, of course, now green energy has also started. People have started using green energy. That also I'll come to that later. But that's first important challenge. Second, digital transformation and talent gaps. So that's the second, and that's where we can contribute, right, as a community. So rapid AI adoption widens the skill gaps, because now everywhere AI is being used. Now what has happened is like even the plants are becoming automated. One point of time when I joined Asian Paints, actually one of our old plant was having say capacity of like what our current plant has, 10 times lesser, and the resources were 650 people were working there. Now just adjacent to location Mumbai, the Khandala plant we have, right, close to Pune. This plant is liquid paint capacity number one in Asia actually, right? It's biggest one, and fully automated. Whatever was done, the 1/7 or 1/10 kind of volume by say 650 people, the 10 times higher volume is produced, and maybe even larger than that, with just 150 people, 150. Now we can understand more and more automation is happening, and now with the intervention of AI, even quality control is like totally automated. All our drawdowns, the kind of colors, measurements, or the parameters measurement, everything is, and inline the process check is there, right? So while the batch is being made, actually the batch is also assessed simultaneously. So that's the kind of automation is happening now with AI intervention. Again, the quality, the consistency, the complaints resolution, everything is happening now that way. So here, then again the skill gap is important. We'll have to also acquire those kind of skill which is important, and require new talent strategies to enhance operational efficiency. Okay. The third one, regulatory and compliance pressures, because government has realized and all negative effects of the chemicals on environment and also on the people. So there are regulations there, stricter regulation environment. Of course, Western world, they are more stringent, and we normally follow them, right? So if something is implemented now, maybe 4 years, 5 years, 10 years down the line, it will come here. So anticipating this will come here, probably the large companies like us, we normally proactively work on that. Supply chain constraints, so potential supply chain disruption caused by geographical tensions, rising protectionism, natural disasters, and logistic issues are downside risk, right? So supply chain is the biggest kind of resource, and a lot of implications, right? Because it's not only you made the product, but after you made the product, it has to reach to the right customer in a manner that it is usable, right? And it has to be stored in a manner it is usable. So a lot of issues are there in terms of storage, in terms of transport, in terms of distribution, right? So that's a very important thing. Now, coming to the science part of it. So this is something which is there on a WIPO report, that is mapping innovations patents and the sustainable development goals, right? How the SDG, so UN has those 17 goals, all of you are aware of, correct? Now those sustainable development goals are jointly, like unanimously accepted by everyone, saying that if we meet those goals, actually it is good for the world, because then everybody realize there is greenhouse gases, there are global warming happening, a lot of those kind of events which is happening, which is putting people under pressure, and then they always want to kind of avoid those, basically, right? As a human tendency is always you want to avoid the kind of risk, right? That's the natural human tendency, and always we try to also implement in our industry. So this is the innovation maturity matrix, where you can see, like on the x-axis, relative recency, the recent development, versus kind of innovation intensity, right? So this mapping is done, and then all different sustainable development goals are mapped there, right? So we have some pointer also. Pointer we don't have. Okay, can you see the uppermost corner actually? So that's the corner which shows the kind of SDG goals which are highest in terms of the recent development, and also they have got high innovation intensity. Innovation intensity is measured in terms of how many patents in that particular area is published by people, right? Scientists. So that means that area is very much research area, right? And recent means it is like new, so newness part of it. So both of them, if there is higher, so you can see SDG 9, SDG 13, 7. So these are typically like industry innovation, infrastructure, sustainable cities. Now people are talking about smart cities, right, in India. So our Prime Minister announced smart cities. But in smart city, lot of those innovations will be appreciated, okay, and be implemented. The 13th was climate action. Then third one is good health and well-being, and seventh is affordable and clean energy. Right, nowadays energy has become important, and more and more clean energy people want to use it. You'll surprised to see like these days we work with the Indian Railways. Now Indian Railway network is the largest network globally. Whatever commute that happens in India, nobody in other country happening in the world, right? It's very large, and here, as it is large, any impact of energy is also large, correct? Now if you see how many of you have traveled in Mumbai train, local train, okay? How many of you have seen Mumbai local train? People traveling, commuting, yeah, it's if you have not done, please try once in life. So people are talking about sustainability. In US, the kind of resources they consume is 5 times more than what Earth can produce, right? And if everyone, rather it is 8 times. If everybody start following them, then average will be 5 times. Now imagine, so even a typical family of 4, we have 4 cars. Each one is trying with our individual car, right? Whereas in a cities like Mumbai, one train, almost like whatever capacity, double of that capacity will be carried. So you can see how sustainable. And then this is electric train, right? People are now talking about electric car, electric vehicle, etc. It's a clean energy rather. Of course, if it is produced by some cleaner means, if it is thermal energy by say fuel burning, then that is not, maybe it is generally more COD. Of course, there are different type of energy, but yes, in short, it's a clean energy, electric energy, and that's how like each one is traveling with most sustainable way. And the carbon footprint, if you calculate for a person who is staying that way, he is eating maybe one vada pav, most sustainable, costing 20 rupees. Now in Mumbai, anybody can sustain, right? You are talking about sustainability. If you don't have enough money and be sustain, yes, people can sustain with minimum expenses, right? And you can travel more sustainable way. You are not contributing much in the carbon footprint, through carbon footprint. So why I'm saying this is basically that the energy consumption, right? So it's a clean energy in railway now. So globally, this is challenge. An industry, whatever process that you create or you develop the kind of process in a lab, it has implications, right? In a lab, we don't realize the small scale. Okay, you're just heating, the cooling and all kind of washing, etc. But when it goes to a larger scale, it has a lot of implications. So we have to be always in presence of, also in mindful of that. Okay, what is going to happen when it is going to the production? Just like John Warner, he realized after he invented 300 molecules, he realized that okay, I was not looking at this aspect, that what is happening after I develop this, what is happening in plant, how the kind of ETP is generated, what is hazardous which is generated, right? What multiple step is causing to environment in terms of global warming, etc., etc. So whatever we do has implication, and we have to be mindful in that. Okay, so that's the affordable and clean energy part of it. So these are the key important 5 SDGs, Sustainable Development Goals, which are highest in terms of the recency and also in terms of the innovation intensity. And a lot of kind of patenting is happening, whether it's the global patents or the even nowadays the patent trend is like Chinese patents are more frequently you can see, right? A lot of patents innovations happening in that area. So next one. Yeah, next. So at this stage, any question regarding whatever we discussed so far? Yeah. Okay. So continuing the same flow, like so we have seen the kind of patterns, but these are the kind of key areas that if you segregate those patterns, so it is coming that way. So global innovation matrix, sustainable chemical industry. So key areas of focus based on the patent trending. Okay. So the first one is feedstock transition. So high patent activities are observed in bio-based feedstock like sugar cane, algae, waste biomass, CO2 capture, CO2 utilization, right? So that's one area which is important. And emerging technology out of that is green hydrogen, synthetic biology, microbial protein, etc. Yeah. And I also know that in our department also, like some of the activities related to say bio-based polyol, etc. I think past I was part of some of those developments here. This is how actually it's relevant now. Circular economy is another area which is like highly patent, means more and more patents are done in this area. Chemical recycling, that is depolymerization. Nowadays people are kind of collecting the chemical, means the plastic waste, and kind of go for depolymerization. Like previously people used to dump it or be incinerated, but now they kind of get back the monomers. And some of the plastics like polymethyl methacrylate, they get almost kind of 95, 90, 98% kind of recovery, and the same is utilized again. So it's a circular economy. So circular economy is basically, it's not that you take something and you make out of that whatever you taken and kind of use it and throw it. So that's a conventional way of it. But circular is like you take the material whatever, you make it in the way you want to decide, and then use it and reuse it. Reuse it, reuse it. So that it kind of go into that circularity. So chemical recycling is better. So previously mechanical recycling also was happening, right? So now chemical recycling is better than that. Process efficiency, electrified heating, low energy catalysis, and product innovations which are biodegradable polymers, as I mentioned, sustainable coatings, performance additives, right? And then digital enablement is AI-driven discoveries, digital twins for manufacturing. So lot of those. So you can see the interdisciplinary kind of knowledge creation is also you can see here. Okay. Next. So this trend ultimately results into a rise of smart sustainability actually. So this is the output. So chemical companies are increasingly merging AI, big data, robotics into R&D to accelerate the discovery of green chemistry solutions. And this is more often happening in the field of, I think some of you might be from pharmaceuticals, right? So a lot of those interventions you can see there. Second is green hydrogen and storage. So now this is again a greener source of fuel, right, to the conventional petroleum fuel. The next one is regulator-driven innovation, where there are regulations, stricter EU Green Deal, or the US TSCA reforms, or carbon pricings are forcing patent filing also in this area, actually, right? So, like for example, there are now limitations or the restriction on usage of the fluoromaterials, fluorocarbons, HFCs, etc. And also VOCs limitation there, hazardous air pollutant limitation there. So again, you are kind of forced to give a solutions. Many of the customers, they come actually whenever they want to export, they ask for so many declarations, right? And now it is EPD directive, right, where you have to declare the kind of hazardous associated with your product usage, and that's where the companies who are supplying or who want to supply to Western world have to kind of mandatory comply to that. So this is something which is important. You may have a product, the product might be performing, but if it is not having those elements of sustainability, it will not be used. Specialty chemicals leadership and shift from mechanical to chemical recycling. So sustainability focus on smarter, cleaner and high performance value-added application in nutshell. So that's what the patenting trend is, right? Clear? Any question in this right now? So you have defined the sustainability, we also discussed the challenges, the opportunities, and the metrics also, and the whatever patenting trends in this area, so what are the different areas. Okay, next. So coming to now from global to India. So what is happening in our country, India? So basically, India ranks as the 5th most significant chemical producer. So we are number 5th, and in the world, and in Asia we are 3rd, right? So we are manufacturing 80,000 commercial products. It's a huge number, right? 80,000 the products are being made in chemical sciences, related to chemical sciences. And so it includes bulk chemicals, specialty chemicals, agrochemicals, petrochemicals, polymers and fertilizers. So there are different verticals. Okay. In India, chemical industries are contributing about 7% of the GDP, which is good amount. So it's a huge contribution. And through agriculture, pharma, textile, auto, and construction industries, right? Everywhere it's used. So, how many of you know that in construction it is used, chemicals are used? Construction chemicals is again a very specific domain, and a lot of good products there again, right? So chemistry plays a role, very vital role in every segment, whatever application we talk about. Yeah. So if you talk about the size of the industry, then India chemical industry is valued at 21 lakh 50,750 crore, right? So it is also difficult to read actually. US dollar 250 billion in short. So that's 2024 figure, and 2030 it is going to be 400 to 450 billion. It's going to be almost double. Can you see that? So that's the opportunity. That's the opportunity because India is going to be the hub chemical, right? So the world is looking at us in terms of, and now also that our owners' responsibility is to see that we kind of meet those expectations, right? So why world is looking at us basically, of course, conducive environment, and also the kind of workforce we have. All of us we contribute actually. So that's makes a difference. Now, with global demand rising, investments in downstream manufacturing, government incentives, manufacturing, the sector expects to reach 86 lakh crore, that is by 2040. And these numbers looks like okay imagination now, but we are witnessing actually. Recently we are working with railways, and they've announced right now that the number what they have actually. So whatever comment the people comment, right? So that number they want, like currently it is 24% people travel by train. Now that 24 to they want to make it double, 47%. And in doing so, it will need double kind of infrastructure, tracks, the train, the coaches, etc. Similarly, wagon, the goods carrying industries. I mentioned the transportation is very important aspect in sustainability, right? So cheapest transport is by rail, right? And that's also cleanest also because electrical energy. Okay. And there now government is putting almost double. So currently it is 1500 million metric ton annual. It is going to be 30 million metric ton by 2030, and 2030 is not very far actually, just few years now. We'll have one or two more conferences like this, and you will have this 2030 nearby. So it's very fast. Time is passing so fast. Yeah. So it's not very far, and you will see this number kind of, and we are experiencing actually. So recently I've been witnessing those coach manufacturing, the wagon manufacturing. So there, when we go basically. Currently, so suppose one line is producing say 250 wagons per month. Now the same guys are asked to develop and do 500, like 250 to 500, double almost. Now overnight they cannot change the infrastructure, right? Because so many constraints, the cost constraint, space constraint, people constraint, etc. So what they do is like they seek support from everyone. So a paint guy has to come, and they said, okay, if your paint is kind of taking 2 days, 3 days application, can you make something which can be applied in only 1 day? Now that's kind of challenge for us, right? Okay, something is producing some VOCs of say 250 grams. Can you make it something 100 gram per liter? Now those are the kind of expectation which comes, and it's not only that you have to meet the performance and the green also, but at the same time cost and the speed of innovation. All of these are important. So you have to meet the performance, you have to meet the sustainability. Sustainability is like previously it was kind of fancy word. Okay, we should have sustainable development this and that. Now sustainability is a part of the annual report of an organization. You know that? It's part of annual report. Previously it was like separate sustainability report. Now it's part of integrated report is containing both ESG and the company performance both. So you can understand the kind of importance of the sustainability in industry. So the CAGR of 9 to 10% as I mentioned, it's a huge because global it is 3%. This is going as almost 3 times higher, and that will bring a lot of challenges. The export also increasing, and with dyes and dye intermediates adding 20,000 crore during April to February 2025. So it's a huge export. Of course, there are a lot of also negative impact because you can see like the belt right from Vapi to Ankleshwar and all those bits, right? There are a lot of those dyes and pigment industries. and there are also kind of sometimes we have seen like the dogs which are coming out of the industry also of different colors, right? And people also like they work continuing. So yes, I think it has implications, but that's our responsibility as a researcher or scientist, basically how we can make it better. Yeah. So it's responsibility. It is also opportunity for us to work in a manner to improve the kind of well-being of people. So well-being of people is also one of the sustainability development goal globally. Okay. So India's ranking as fourth largest agrochemical producer and as a producer of dye stuff and intermediates further increases the likelihood of becoming a sustainable hub, high chemical manufacturing, right? So this is what we have been seeing now. It is happening. It is happening. Okay, next. So Indian chemical industry is slowly turning into more sustainable one, and the emphasis is on green chemistry and principles of circular economy. Okay. The relocation of non-renewable petrochemical feedstock to biomass-based material is one of the steps in this process. And there is another term, I don't know whether you have heard this, Bio-E3 strategy. This is government supported strategy actually in doing the developments in the biochemical sciences. Right, so those who are in biochemical science, a lot of opportunity to contribute. Okay, and India also producing bio-based specialty chemicals, enzymes, and biopolymers using agricultural residues, industrial waste, and this residue, the dependence of petrochemicals, and opens new frontiers of high value and friendly products. Okay, next. So. Yeah, so this Bio-E3 is India's strategy to build future, right? And very, very strong sustainability elements you can see here. So Bio-E3 stands for economy, environment, and employment. All the three elements very strongly here. It's India's national bio-manufacturing strategy aims at transforming India a bioeconomy and bio-manufacturing leader by integrating biotechnology and engineering and digitization and sustainability. All four aspects are covered. Shifting India petrochemical based industry to bio based and low carbon high value manufacturing. Now this particular initiative, you can see like the 6 particular sectors, the thematic sectors will be served. Bio based chemicals and biopolymers and enzymes. A lot of work is happening in this area. Even now people are talking about those particular polymer synthesis which typically in lab requires say 200 degrees centigrade temperature or 250 degrees centigrade temperature for like several hours. Those kind of high energy intensive processes are converted into room temperature synthesis by enzymes. That is happening now. It is happening. It was like science. So some of these international conferences, they have a theme called science today, technology tomorrow, right? And I love this particular session. So it's like conceptual work is discussed, but those concepts subsequently gets converted into products and technologies, right? So I think we as a creator, we can be good in sometimes creating the concept, and some of scientists, they may be good in terms of converting those concepts into products and processes, right? Everyone like is blessed by God in terms of different abilities, capability. So whatever we have got, actually we have to utilize it. Okay. So bio-based chemicals, biopolymers, enzymes, functional food and smart proteins, and precision biotherapeutics, climate resilient agriculture, right? Carbon capture utilization, and marine and space biotechnology. And when they have chosen this segment with lot of deliberations, and you can see like that, because India is basically a agro-based economy, right? Agro-based economy. Even today also, like India lives in the villages, right? Of course now smart cities and everything is coming up, but still it is there. So why not to make it stronger? So with all kind of biosciences and biotechnology, it is kind of helping there. So the circular economy in its turn can offer India enormous economic and environmental possibilities. The country generates about 62 million tons of waste. Now this is a very important aspect. So every year 62 million metric ton waste is generated. Now yet around half of this is deposited as landfill. You might have seen like out of the city, there's huge heap of waste generated, like piled up. And this is big challenge in metro cities also. Like and if somebody staying around us, actually you will have typical bad smell also of that coming out, right? So this is challenge, and of course there is opportunity, because then that particular waste is something you can generate something best out of this, if possible, and that's the effort. So here 62 million metric ton is a huge waste, and suppose With the full of this, it utilized the Economic Advisory Council of Prime Minister projects 2030 to 50. This will amount to 19,200. No, 19 lakh 2200. So I make a mistake always there. Easier is 280 billion, 18 billion USD. That's the kind of potential it has, right? So waste can be utilized, and this is happening now. One of the scientists I know, he did his PhD from the IIT Bombay, and he is like startup kind of firm basically in North Gujarat somewhere. He has started his unit. What he is doing is wonderful. So he is a scholar actually, and after studying a lot of things actually, he on his own actually he did some research, and because India economy is agro-based and also cow and animals, like in villages you can see the buffaloes and cows still are there. So then he thought of like how to convert this particular aspect into gainful something valuable for the society and for the people, right? So and also that way kind of it can avoid even animal killing also, right? That's also one of the aspect that humanity, we have to respect everyone. All are Lord's bacha, so we have to respect. Now there it shows, and he has done a lot of research, and there are a lot of books also. There's he called it Cowism. Cowism is a book he published, it's wonderful. So he created a nanocellulose out of the cow dung, and I myself have tested it all, performance and everything, a lot of characterization, all advanced methodology, etc. But this nanocellulose is almost equivalent. There is absolutely no difference between like if you synthetically or with normal cellulose if you can make something versus make from here. This process is so benign that there is no energy used there, right? Only like natural process, just some of the filters and some of the kind of centrifuge machine that is had. Very simple infrastructure, and he is making the best high value added product out of cow dung. So I was very much impressed, and kind of is a very good friend of mine, and I can see like these kind of people can really make a difference. Yeah. So I think he's also, if some of you want to kind of search gobarwala.com. The name is gobarwala.com. You can just Google and see the kind of innovation that he brings, right? So why I'm saying this? Yeah, because of this kind of waste, right, is piled up. But then waste you can kind of convert into kind of useful resource also. Okay. So anyway, this is future, India's future for sustainability. So chemical industry in India contributes significantly to GDP, supplies key input to agriculture, farmers. So that will continue through green chemistry, circular economy practices, renewable energy adoption, bio-based material. The sector is reducing environmental impact. That will continue to enhance the efficiency, and digital or interdisciplinary aspects also will kind of improve further. And through policies like National Chemical Policy, PLI schemes, Green Hydrogen Mission, research. So there are a lot of initiatives actually. All those CSIR labs, they have got Innovation Incubation Center. How many of you are knowing this? Like CSIR lab, they have this. So anyone startup, you want to kind of create something on your own, you want to be like proprietor of some company, right, tomorrow, can be, right? So you have some good concept, you don't have infrastructure or resource, anything, you just go there, kind of present your concept, kind of government will provide kind of aid, the financial aid or the kind of resources that you want, some small lab setup, the fume hood or something to work, everything is available there, even the canteen food, everything. So it's so good actually that there is a lot of this. Only thing what you should have is like kind of zeal to work, and you want to contribute to the kind of community, right? That is the only thing required. So and you have the best idea. So yeah, that's future of sustainability, and leveraging innovation, policy support, sustainability initiative. Okay, let's go. So in terms of the process in chemical industry is basically you have a feed, right? So how the entire value chain kind of has implications in terms of the activities. So whatever activities we do, it has implication. So when we extract the raw material, it has implication. The way it is extracted, the source, the kind of process, the way it is transported, all basic chemicals. So first you will have olefins, kind of simple building blocks, aromatics, like some solvents, etc. chloralkalis, methanol, bio-based materials, sugar, etc., ammonia, simple building blocks. So we'll make those building blocks. Then comes the chemical intermediates like those commodity or differentiated commodities and technical specialty out of this building block. And then you have a formulated products and the product materials like plastics, engineering, some of the polymers, resins, right? Which may not be the end product, but yes, this is base material for the next value chain. Bio molded parts, injection molded parts, components, composites, paint coating is also kind of intermediates that way. And then you have the automotive, transportation, consumer products, packaging, medical products, etc. Right? Now we can see the different stages. So industry approach to sustainability is basically minimizing the environmental impact at every stage of product or process life cycle across the life cycle of the product. So right from the extraction of the raw material to its processing for making the kind of intermediates, and then subsequently going to the end consumer. Okay, and after it is consumed, subsequently post-consumer aspect of it, right? So everywhere how it has impact on the environment is actually mapped, and if we are doing something about it in terms of minimizing the environmental impact, that is what the sustainable process is. Clear? So right now if somebody says, okay, how sustainable you are you 100%, 30%, 40%? So it is difficult to figure out, right? Now sustainability is a journey of continuous improvement, right? So today, and that's how here comes the technology limitation. So today I have a technology, with this what best I can achieve, right? Because you have to survive. Sustainable means also you have to fulfill the need of the people, right? People need the product, and you can't say that, okay, after say 15 years I'll come with something else, and till 15 years you do something on your own. So that's not feasible. That's not feasible. Okay, so you have to have kind of a product which is befitting the customer needs, at the same time whatever sustainability elements that you can combine, right? So there are standards, there are specifications which specify the kind of product standard depending on the technology readiness of that time, and once the technology evolution happens, subsequently that can also be upgraded further. Okay, next. So so with this, now coming to the examples of sustainability, so that now after the conceptual understanding you can relate to that how companies are doing. So there are two case studies that we want to discuss in whatever time we have available today. We have 20 minutes, fine? Okay. So one is basically a company called BASF. How many of you know BASF? BASF company, yeah? Surprising. Yeah, this is a globally chemical giant, right? BASF, and they are proud to announce themselves that we create chemistry, right? They don't want to shy away saying that we are not dealing with chemicals, right? And a lot of those sustainability initiatives, wonderful sustainability initiatives, we can learn from there. So why does the world need BASF? So the purpose of company, they specify on their website boldly. They says, our answer, we create chemistry for a sustainable future. We create chemistry for sustainable future. We want to use chemistry to contribute to a world that offers a better quality of life for everyone. Okay, now this everyone word has significance. It is not only that you are making something for the customer, and the poor guy who is making the product is suffering. You understood? So your chemical process such that the handling, the kind of smell, the kind of toxicity it has in the beginning. So the person who is making is suffering a lot. Maybe the end product may not be that toxic, but then that is not sustainable, because at one end your set of people are suffering, and for the benefit of just few handful of people, okay, or maybe large. Most important, so quality of life for everyone. In such a world, the economy, the environment, and our society must be kept in balance. So all the three aspects. So sustainability has essentially three very essential, important elements. Economy, because ultimately we are in business, right? And in a business, what is important? The purpose of business is? Purpose of business is profit, money, right? Without money, nothing can survive, right? Resource is very important. Without money, nothing. So economy is important, environment is important. We take care of environment, and we can take care of society, the people, right? All the three aspects. When the three aspects are balanced, must be kept in balance. That is the core of sustainable development, and that requires constant change from people and organizations. BSF has been changing continuously for more than 150 years. It's very, very old company. Today, change means above all that we want to be the preferred chemical company to enable our customers' green transformation. Now, BSF makes a lot of products, chemicals, right? And each product is kind of seen with that yardstick actually, that how it has implications in terms of right from the sourcing of material to the disposal and post-disposal. What is happening to that, correct? So, life cycle assessment is done, and they have internal targets. We'll come to those whatever sustainable development goals that they have, right? And we have been interacting with this company, and we see that yes, they are the one who kind of they are not shying away saying that we are chemical company, right? They are proud. Though I think if there are hazards like Bhopal gas and all those people are aware of, right? People get scared actually. Okay, we don't want to deal with chemicals, but then it's not about the inherent hazard, of course, chemicals have, but the way we handle, the way we process, and the way we kind of find out the ways actually, right? For the safer, for the environment, for the people. That's a key, or that's a strategy one must learn actually. Next, the BSF, the policy of BSF is strong industrial policy fuels innovation, global competitiveness, and resilience. They are very quick in terms of adaptation and global competitiveness. So any technology which they come up actually, a lot of deliberations happens during the development, right? So it passes through several stages and gates, right? So now every company actually, corporates, if you see any new design, product design when it is done, so it is kind of seen from various aspects or various facets. So what implication it has, what kind of implication in terms of the processing, implication in terms of usage, a lot of field trials happening there to understand what is happening when people are using it. Okay, so that's very important. Circular economy is another. So one is policy, second is circular economy. BSF is advancing circular economy, shaping new material cycles, or utilizing alternative raw materials and applying mass balance methods, right? And transition to low carbon economy. They always have a kind of they have internal software. They are on their own. They have designed actually. So there are kind of free software also available, like and also paid software in terms of if you want to assess the carbon footprint of your design or the formulation, or if you have process design, etc. Right? So so that can be done, and when you have like 10-15 different designs or different kind of recipes, you want to assess like which one is better than the other. That is possible. Okay. So they have this internal framework, and that foster, and of course when you have something to meet actually some target, and that pushes the scientists to kind of do more, stretch more in terms of meeting those requirements. Okay. Climate policy, so renewable energy, piloting climate friendly technologies and offering products with low carbon footprint. So that's how they do it. And chemicals environment policy, BSF advocates for science-based practical regulation of chemical substance at the EU. In fact, this is the company who is also one of the important stakeholders in designing the regulations, right? So somebody is kind of bold enough to say that, okay, from tomorrow onwards, I'll not be using this. Now that's very bold, but there is also kind of showing the leadership, right? So when you are a leader, actually, that is expected out of society that yes, whatever you are giving, whatever you are offering, actually, it's the best for the society. Okay. So that's about BSF. You can understand now this is the strong sustainability value system that they have announced, right? And each of the employees are seriously following it. So outcome, yes. So outcome is this, that this is what is a result of that particular value system they are living with. You can see that in 2050 it's a near zero, right? CO2 emission. Then so this is how actually, and that's journey. Now this talk about scope 1, 2 and 3.1. Again, it's a terminology you have to understand quickly. Scope 1 is where the CO2 emission happens because of your raw material procurement and processing in the premises of the company. That's scope 1 carbon emission. Scope 2 includes the energy used from other source, and because of this energy creation, the carbon emission happens, right? You purchase some energy from somebody else, and that guy is also having the contribution to CO2 in environment. So that accounts for scope 2. And scope 3 is basically all downstream users, like subsequently after you dispatch the product from your factory, going to distributor, it is staying there, the guy is kind of keeping this for long duration, his AC is ready for 24 hours a day, right? Now all these accounts for the CO2 emission, okay? Eventually the used by customer. So, and then customer will throw it away in the dustbin, okay? Now whether it's going for recycling, not going for recycling, all this have implication. So at every stage, what is the carbon emission that is calculated? So this is what the target is, and again 50% sales coming from sustainable future solution. Now this is the trend in most of the chemical industries. Whatever products they make, they have a portfolio of products. So right from say super premium products, the premium products, the mid segment or economy products like that. But in each of this bucket, they have set of products which are green solution to begin with. But eventually the movement is that we want to make all the products green. Okay, so they choose a kind of a green framework, and they themselves kind of declare to their business or to their sales team that okay, we want to kind of sell at least 30% of our sustainable solution by such and such date. So they announce it and they agree, and they kind of contribute that way. So and you might be seeing also some of the advertisement where they kind of promote greener solution, right? Some of the air conditioners, so they have 5-star rating, or geyser, water geyser, like 3-star, 4-star, 5-star. So this is nothing but kind of the approach by the industry to promote a greener, sustainable solution to the society, right? People can choose, maybe a little costly because of finisher, but eventually like they also keep working, and they finally the cost will be neutral. The same product, sustainable product, at the same cost. So 50% of this sales from the sustainable solution, right? I'll also come to product part of it. Will relate more actually when we discuss about some of the paint industry product there. Of course, since 2021, we have been collecting product carbon footprint from suppliers. Now, this is important responsibility, right? So global players, they have also taken this initiative where for each of the input, that raw material input going in their products, how it is made by their suppliers, what is their carbon footprint, and whether it is there any implication in terms of the fire hazards or some kind of big hazard though, which can have implication in terms of storage, etc. All of these are worked, and they also support small players. In fact, we experience all this when we interact with their teams actually, right? So when we initiated our green product journey, then we started interacting, and BSF kind of people actually, they all come forward and actually they support us, okay? Sharing the data, okay, what kind of carbon footprint they have, because otherwise it's difficult to get the details. So this is what it is, and 10 billion cells from loop solution. Now loop solution is basically a circular economy, okay? Recycled material. For example, nowadays even companies are asked to kind of use certain amount of plastic packaging mandatorily in their products, right? Of course, we have several products, and then you can see the impact, huge impact. In fact, construction industry is very booming industry, right? In India, a lot of construction activities. Now, I don't know whether you are aware of, but then cement used in all our construction industry, mandatorily certain percentage of fly ash is used. How many of you are aware of this? Yeah. So we have nearby thermal power station here. So and again, it is mandated to those cement factories closer to the thermal power station. So that is directly goes without much transportation energy and carbon footprint addition like that. So government has started this actually all initiative, and everything is monitored to minimize the implication, because if we don't see it now, we initially discussed that consuming resources of 1.8 times of what Earth is producing, how sustainable we are, you can imagine after a few years. So it's a responsibility now that we have to stop it. That's how by 2050, 2030, all big giant, they have taken target, and these are voluntary. Nobody is kind of forcing them. Okay, that's a responsibility. In fact, 1985, the Responsible Care was the initiative. It was a voluntary initiative started by chemical industries globally, and even now also, every countries they have adopted many of those chemical companies, and under responsible care there are set of principles, green principles that they have adopted. Okay, and this is voluntary. It's voluntary, and that's this how actually declaration in terms of sustainability work. Now, as I mentioned before, this has become the part of their integrated report now. Every company you can see, not sustainability report but integrated report, where they call it ESG framework, right? So that has been there. Of course, safety related aspect is also there. Point one, plant incidents minimization and so on. So here very important principle they work with is a core strategic concept of networking or integration. They call it Verbund. Now Verbund term is basically a German term which is nothing but a network. The meaning of this word is or to connect. So this is very powerful tool by which they kind of contribute and implement the sustainability elements is that they create a kind of cluster, and within that cluster actually there will be a unit utilizing particular starting material, and that starting material also is supposed to be made in the similar zone or similar area, right? So they share the common resources in terms of even sometimes like no need of even the transport trucks etc. The pipeline is put between the factories, so one input is coming directly from this pipeline to other, like that. Now it saves a lot of energy actually, right? And a lot of losses are minimized, handling losses etc. Okay, and a lot of safety aspect because certain materials are very hazardous. If you transport on roads, you have experience, right? Some of the tankers are carrying a lot of hazardous, very toxic waste and toxic ingredients. It is very difficult because you never know like what is implication. If like something the tanker is toppled down and leakage happens, it's very risky. I think few days back this happened in our Bombay-Pune highway, and almost people were stuck for 24 hours without food and anything. It was their news. Now, because the tanker toppled down, and the Kandala, the slope and all this. So this is very risky. So I think these kind of clusters when they are there, it is always helpful. That's what the concept Verbund is, the BSF is working with, right? Now these all the ideas or kind of strategies to kind of minimize the risk, minimize the impact, as we mentioned in the beginning. At every stage, every step, how we can contribute. Okay. Next. So here, this is what the product strategy of BSF. This is product strategy. You can see, right, triple sustainable solution steering. So they have a segregation of product like this. So the topmost you can see the pioneer. The pioneer products are basically and a loop solution. Okay. The outperforming the market with benefits to the list at least one of the life cycle transformation topics or other sustainable categories. So every company has got their own green framework or sustainability framework, and they map their own products on sustainability framework, and they identify that these are the products, set of products which are called green as per my definition. Okay, and they kind of put them under the pioneer category, and subsequently less greener will come into second category. Then lesser greener will come into kind of standard category, which are not very sustainable but yes, okay product. Then there are set of products which are identified having some issues, maybe a kind of hazards. And today suppose a particular ingredient is kind of hazard is assessed by, because not all the materials are kind of assessed totally, right? The hazard assessment assessment is continuous. The REACH process, how many of you are aware of REACH regulation in Europe? So it's a regulation which restricts the usage of toxic materials, right? And you have to register, like there are a lot of processes there. So even now, since India, we are supplying to say a European country, we have to also mandatorily fulfill that. Now, in this case, the compliance becomes important, and you have to map those products. Okay, so the product which are kind of in a zone of orange or red is where you have to be concerned about, and those are closely monitored. Whenever you find any alternate to that, or wherever you find some alternate solution of product altogether, those products will be out from the market, right? This is voluntary initiative by organizations. BSF has done this actually, and same you can see like other companies also. So this is the approach in terms of sustainability driven product formulations. Okay, so and they also have kind of given the target to their business team, and this is with alignment that okay, we want to offer only those products which are sustainable and irrespective of their current cost, etc. Let's kind of push those products, convince the customer, and explain that these are the benefits, and kind of trying to promote this. Okay, so that's how it happens. Okay, so the loop solution is circular products based on renewable or recycled materials or support the recycling process, closed loop as the loop, and as well as the products that increase the durability or prolong this lifespan of material. Now, there are two ways it is addressed. One is that of course, if it is recycled, it is fine. Even if it is short, product life cycle is okay, like lifetime, right? Durability. But if you can offer something which is like having double of durability of current product, right? Then it's more sustainable because you are cutting down one application cycle, one usage cycle. If durability is 3 times, 4 times, you are reducing the 3 to 4 times application. So that's how every year we kind of try to put these aspects actually of improving the durability. Now it can be done by all our chemical science. We are the contributor basically. So through nanoscience, we can kind of enhance some of the aspects of sustainability or durability. Through some of the newer technology like biotechnology aspects, we have said enzymes, etc., newer enzymes, right? So those are the things which can help. Now carbon nanotubes widely used, graphene actually, we have a few products like that. So how we can do some innovations which can be more sustainable, and that's how the relation of the innovation and the sustainability, right? So sustainability driven innovation, we'll come to that later also. Let's go next. So the two examples of the applications here, BSF, there is one insulation material. This is derived from the kind of recycled material. This insulation material is helping the building with the insulation such that the hot remains hot, cold remains cold, right? So in a countries like Europe, wherever they spend a lot of energy in maintaining the room temperature, heaters, right? Recently I was in Dharmashala, so you know that cold season, it's like very, very cold, and without heater you can't survive in a room, right? It's very cold. Like temperature is 0, 1, 2 degree type of temperature. So so there actually this is very important where you have the insulation covering on the building, and then you can save a lot of energy for HVAC, like so heating, ventilation, air conditioning, etc. So energy saving that way. Then shark scheme. So biomimicking, I think all of you know biomimicking is a very buzzword actually, and people have been making because nature designs the product which are perfect in usage, perfect in application. You can see the packing of like banana or orange, right? Wonderful packings, the fragrance containing packing, right? And they are so nice actually, and 100% biodegradable, absolutely nothing, no harm to the people. Even packing people can eat also without any issue, right? So that's how the perfection in nature, and so people have been trying to mimic those applications which are mimicking the nature, right? So this is a particular film which is made by mimicking the shark skin, right? And shark skin is having some of the ribs kind of profile, and this profile you can see in bigger, so that the film you can see the dotted films, and this dotted film when it is used on the aircraft, right, it kind of reduces the fuel consumption because of the avoiding resistance to airflow, right? So it's more of aerodynamic, which helps actually going smoothly without resistance, and that reduces the fuel consumption to the tune of 20-25%. Yeah, and this is something which is kind of adding value to the end customer. So these kind of application where you are designing something for the end consumer, they are called sustainability enablers. I'm making a product for people which will add value to his sustainability meeting goals. Next. So coming to paint industry, so I don't have much time. How much like I can use? 5-10 minutes, okay? Okay. You guys are okay with that? Okay, just few example from paint. So thank you for this your time and attention, please. So sustainability driven innovation in paint industry, which I am coming from. Yeah, here you can see that this is composition of paint, where you have the solvents, then water if it is solvent, right, or additives, binder, pigments, etc. So if we kind of bucket them in terms of the aspect of sustainability, so if you see from sustainability lenses, now you have this lenses, right? Sustainability, you can see it. So see that toxicity, so there might be carcinogen material, there will be mutagen, protoxins, hazardous air pollutant, etc., right? Phthalates. Now suppose tomorrow if I have a product and I don't put phthalate. Now phthalate is ideally not supposed to be there, and I advertise okay phthalate free. So that's a wrong claim, right? It's a greenwashing. They call it greenwashing. You're cheating the people on the name of green. But ideally, if I would really be a green, then I have to see thoroughly every item, right? And then thoroughly assess them, and then kind of comply to some international global green standard. And then after getting that standard assessed by third party, then I can announce it. So I'll come to that. We have certain products which are like green certified by international standard, right? That's the real green. Then renewability, renewable energy, renewable raw materials, bio-based raw materials, materials of natural origin, etc. And then circularity of recycled raw materials waste from other products of steam, reuse of waste generated. Even in many of our products, we are using the recycled plastics. Okay, our own buckets we buy it back and then we use it like that. And LC analysis we do for service life, coverage, energy conservation, etc. Right? So we always emphasize on higher sustainable products, more durable products. So the efforts are more in terms of today I have a product which is sustaining for say 10 years in the market, right, or in the field. Now tomorrow our efforts will be like how can I increase the service life from say 10 years to 15 years, or if it is today 15 years, how I can make it 15 to 20 years, so that it will reduce the cycle, painting cycle at the my customer end, and that is more sustainable. Okay. Okay, next. So anyway, these are different products having sustainability elements like heavy metal free, some of the low VOC products, water based greenhouse, this lower GSE kind of products, CMR products. Like we also have one agency in India which is Green Pro, like Indian Green Building Council, and they have also certified the products in the premises where it is made. So that's also there. So we have Green Pro certified. GS11 is the international standard, US based standard, and very stringent standard actually, right? Very difficult to comply. And we have certain products like raw ISTAR, etc. These are also in durability. We have certain products which are 15 years. Now we'll have 20. We also have already 20 years kind of products, durable products, right? Like that. Okay, next. And these are the different kind of sustainability elements that in terms of the process that we take care of. Energy efficiency, renewable energy. Many of our plants are using 100% renewable energy. Yeah, 100% renewable energy. And we also have our own fields where through solar energy that we have been running our plants also. Yeah, and you can see the buyback scheme actually. Asian Paints cans, we get the cans back actually and then utilize it again, recycle it. That's kind of approach. Also, there are products which are having a nature positive impact. Then water efficiency, all our plants, I think we have zero discharge, not a single drop of water going out of the plant. This has been there last 10 years actually, and without kind of making buzz of this, we have been continuously working, and now we have the products. The certification is very easy there, right? So that has been there. Efficient supply chain, health and safety. We continuously working on safer products for people, right? Next. So again, these are the challenges because green is not easy. The moment when you go for green, actually, so you lose something because it's kind of dancing on a moving platform, right? Moving platform पर dance. I don't know how many of you have experienced. So platform भी difficult होता है. So then how to balance it actually? Balancing performance, balancing cost, balancing sustainability, all the three aspects to keep balance is kind of very difficult. But yes, I think that's challenge, and as a scientist we enjoy that, right? That suppose at the end of this thing is come up with some solution. That's a kind of satisfaction, and that's a happiness that we derive out of this. So low VOC, we have to use those pathways which are there. I think for the time we don't have too much time. Okay. You guys are okay? Yes. Thank you. You have a nice audience. So. Thank you so much. I appreciate it. Thank you for tolerating me. So, yeah. So low VOC, yes, there has to be those technical parameters you have to tweak them in terms of making the binder chemistry, like low glass transition temperature. I think those who are from polymer will understand. Polymer TG is important there, co-solvent or other aspects. So last is performance. I think those who can understand the paint will understand the paint performance. But otherwise, as a paint, you can see only the colors, the kind of film which is sustaining. But there is a lot of science going there. In fact, you will surprised to know that we have 280 scientists working in our R&D, the paint R&D. You can see only colors, but then a lot of science there. So, okay. Now, then CMR free, HAPS free, etc., RCS free. So we try to eliminate. So we identify some of those toxins in our formulation, and there is target we take actually to eliminate year on year, right? It has impact. It has impact in terms of cost. We approach different giant like BSF or Dow or other companies, and then kind of work with them collaboratively, develop, sometimes co-create the solution, right? And then implement those. Yeah, there are many examples where we have worked with them and kind of come with a solution there. Yeah. So next, yeah. So our journey in terms of the green is we started some of this aspect of lead removal when there was no regulation. I don't know whether you know that in India there is a regulation on paint in terms of lead free, right? Lead free petrol you have heard, right? Because you might be using it. But paint also lead free. 2017, October 2017, this kind of new regulation got implemented. All domestic paints, not industrial, domestic paint which is coming in contact with human, right? So they have to be lead free. So that is did actually much before the regulation came actually. So we always try to be proactive, and I think I heard one of a gentleman saying that the proactiveness is a sign of maturity in whatever we do, right? So if you are proactive, it shows that yes, you are matured enough in terms of visualizing what is going to be the future and be ready, future ready. So future ready is also one of the expectation we have. Now 2013-16 then we removed all VOC, and then we have green labels, etc. And 17-20 we have now GHG reduction. Of course we kind of try to match with the Indian expectation, government expectation also, because government India also has some target taken in terms of the greenhouse gas reduction, etc. So we comply APO free indoor air quality, and of course we got many FICCI awards also. Every year we get, last year also we got FICCI awards in terms of green innovative products, etc. Then 21-24 we have now proper ESG framework in place, and if you refer recent any of this year or last year or subsequent last year reports, you can see our ESG framework and all these green initiative. Whatever I discussed today, you can also kind of understand and kind of validate that same thing. So now we are discussing about scope 3 emission, sustainability development goals, how to contribute there, healthier living spaces and backward integration. In fact, we have started now working on not only polymer but also the monomers. How can we make? So in fact we have now recently upcoming plant in Dahej, so that is that will be for vinyl acetate monomers, and we'll be making, so we are making our emulsions. We are, I think, number 2 now in terms of emulsion producing capacity here, right? We make our own binders polymers there, and there is possibility here we'll be using our green feed also, like bio-based monomers as well going forward. That's what the scope 3 emissions and backward integration. Next. So the journey appeal continues, environment and product stewardship. So product stewardship, the terminology, how many of you have heard product stewardship? Product stewardship, okay. So anyway, product stewardship is, in simple term, you are making a product. It is your responsibility to see that right from it is made to it is used and disposed at every stage, what are the implications it has, and you are kind of making people aware and taking care of, responsibly care of the kind of hazard, okay. And under that, lot of things comes actually, right? Lot of things come. Suppose if my customer is kind of unaware of using how to use the products safely, then it's my responsibility as a product manufacturer to guide him, educate them, right? So then tomorrow, then if that consciousness is there, then I kind of proactively make some kind of leaflet in a language which people understand, right? and then kind of educate them. Okay, so that's a kind of initiative that comes from this stewardship. So 38% revenue contribution from sustainability advantages products. So this is the huge target we have taken actually, right? That almost close to 40%. Later on it will be 50% products. Almost 50% products we have completely taken care of. Okay. 39,000 metric ton CO2 emission reduction, 6.8% renewable or bio-based materials, and we try to use more of oil-based plant-derived products actually, right? LC of the product. We also do the life cycle assessment. We have those softwares available with us actually. We kind of assess the product processes, etc. And environment point of view, 69% reduction in scope 1 and 2 emission, whatever in our control, both processes and also the energy part. The third part I have taken, I think, in the later part, that how in that journey I showed that how we are going to reduce that scope 3 as well. Next. Okay, previous one. Previous. You can see 20,000, almost 20,150 metric ton recycled plastic in packaging. So this is something, otherwise this much plastic was original plastic we have used, virgin plastic, right? So that much we have just replaced just by recycling. Okay, so we buy back those cans using our packaging material. So we have kind of arrangement with our packing material manufacturers, and kind of use it accordingly. Okay, sometimes 20%, 30%, 40%, and some of our product, totally green product, they have 100% recycled packaging material, right? So that's also there. Okay, next. Yeah, so innovation which are driven for by the sustainability, right? And here comes the material science, and those who are working in material science here I can relate to. So there are products which are based on graphene. You can see this particular product, Ultima Protec. It is based on this particular technology. We have ceramic microsphere based products, and we tied with 3M, a global giant in terms of material science solutions. Inorganic silicate based high durable products. Then we have some of the silica based, special silica based, which are providing more durability, also very high surface hardness, scratch resistance, etc. products. Right. Next. Yeah. So these are again the products for photocatalytic, where the air cleaning aspect is there, or some nanoparticle based solution which are for the glass coating and for making or keeping it clean. How many of you have seen like aircraft where they kind of every flight come and then kind of clean the glass, right? So then these are self-cleaning kind of glass. We don't have to clean it repeatedly. Then nano zinc oxide base, of course, and then colloidal silica base products. Next. Yeah, self-healing. Any scratch or anything happens, then it heals on its own. Microencapsulation, hybrid polymers, and tailor-made polymers, etc. So these are the products you can, when you see the container, you can relate to that this is sustainability element that is there in this particular product. Okay, next. So coming to now the conclusion part, this last slide, and what we have discussed today here is right from defining the term sustainability. We also have discussed about how sustainability and green they differ, right? How people make false claim and called greenwashing. Mirawala green, right? My green is better than your green. Then what are the different elements of green? What are the challenges of chemical industry? What are the potential opportunities for us to work, right? And how do we take care of these sustainability elements sustainably, and kind of come to various innovations? How different companies like BASF, they kind of take care of sustainability, and we have seen through his examples that how those kind of initiative helps not only a company as a whole but also to their end users like us. We are using some of the products of BASF, so transforming the process at the customer end. And at the end we have discussed about some of the paint industry related initiatives, both in terms of process innovation, also in terms of the product innovations, and how companies ensuring that in terms of promoting the products, how the green and sustainable kind of products should be promoted for the overall well-being of everyone, not only the end customer but also the people who are making the products.
at the end, right? So sustainability is a way of doing business at chemical industry. It's not just a fancy word, but it's a part of this business strategy. And now we can see, I think it is very much part of that. The organization's innovation programs are driven by sustainability, and sustainability addresses the core issues of environment, energy, health safety, and economy at chemical industries. Okay, so with this, it completes the discussion. I would like to acknowledge the organizers here and for organizing such a wonderful conference 2 days. So all my best wishes for all of you to enjoy all these subsequent sessions. And I thank to Asian Paints management for allowing me here today before you, and also my Vice President Rajiv Kumar Goel for encouraging all the time. Dr. Subrahmanya Sripati, some of the PPTs, he helped me actually, and Mr. Shikar Naik, Raj Padia, my superior there, and of course all of you for making all this. Thank you so much. Thank you so much. Yeah, if you have any quick question, one or two, yeah, please. Sorry, I forgot to ask you. I should ask. Yeah, please. Anybody can give mic so you can, all of us can. First of all, thank you so much for, I think you were the first person to respond to, and you are the one who asking us. Thank you, appreciate it.
Thank you, sir, for your beautiful presentation. In one of your initial slides, you talked about the recycling, especially in one of the portion it was recycling, mechanical to chemical recycling. So, as we see, maybe the recycling of plastics, or so we see there it involves pyrolysis. It involves what we call that. And all this pyrolysis. So, but actually, basically, pyrolysis is the breaking down of big polymers into small hydrocarbons. But it, as we see, it requires almost 1000 degrees Celsius heat. Secondly, it produces almost 2.5 kg of CO2. So, do you think still it is sustainable? Or would you throw some light on it?
Very, very good question. Very good. Appreciate first of all. Yes. So, coming to your question, basically, see, incineration is done at very high temperature. Incineration is like burning off totally, right? Now, that's where actually it is not sustainable. But the depolymerization is not requiring such a high energy, first of all, to clarify this thing. Secondly, nowadays there are catalysts or process which use some of the catalysts where whatever strategic molecule, for example, you have PET bottles, and if you want to depolymerize PET bottle in a certain specified molecule weight or archetype of the polymer, etc. Now there are processes where people have been doing it, right? So there are polyester resins available in market having certain percentage of polyester which is recycled chemical repository. Now physical means you have PET bottle, just you are throwing in the garbage, they are collecting it, washing it, cleaning it, then scrapping it, cutting it, and then kind of they put it in a maybe PET bottle plant where the injection molding, action molding, whatever process is happening, they put in and they use it, some percentage. Now that is mechanical way of recycling, right? Which may not be as sustainable, but so it is going 1 or 2 recycle then further because the mechanical property will be getting deteriorated. But then if you get kind of a monomers back or oligomers back, that is going in the making the polymer itself with strategic architect of the polymer, with defined molecular weight, defined functionality of the polymer, which can be utilized in original kind of making article, whatever you want to make, so casting or injection molding or coating or film, etc. Then that's the best way. So that is how it's physical versus chemical recycling. Yeah. So it's incineration. Yeah, I understand. Because incineration is costly. See, for incineration of industrial waste, you have to spend money, right? Some of the industrial waste, which are like polymer based or burning actually, right? So we are sending it off. There are few recyclers and there are few incinerators. Commercially, they are kind of doing this activity. And for that, typically right now the cost is we spend 25-30 rupees per kg just to get rid of this particular waste, right? So that's how it is. Some of the cement industry, they use it as a fuel, right? That is another way that people use it, but that is not the right way of using it. The right way is ideally, like whatever is there, to convert them back into 100%, ideal 100%, right? But 100 never happens. It's 90 plus 95, whatever best you can do. People have been trying. Someday it might happen also, because research you can't put full stop at any time, right? Today maybe it's a limitation, tomorrow it may happen, right? So some of you might do it. All the best.
Thank you.
Yeah. So thank you so much finally.
Thank you, sir, for your enlightening lecture on sustainability, the global trends transforming chemical industries. Your powerful insight that in college we are taught what a reaction is. We learn mechanism, equations, yields, and products, but we are rarely taught how to carry out a reaction in a green and sustainable way, and more importantly, what happens after the reaction is complete. Chemistry is not only about conversion, it is about responsibility. You clearly explained the current challenges faced by chemical industries and highlighted India's forward-looking Bio-E3 strategy and BASF for building a sustainable future.
Thank you for guiding us forward, thinking beyond reaction and towards building a sustainable.
Now, as a part of token of love and respect, we would like to invite Dr. Rohit Dave sir to present appreciation letter to Dr. Randhir Parmar sir. Thank you, sir. It's time for our lunch break now. Delightful lunch is served in the dining area of ISTAR.
All the participants are requested to kindly hold themselves on mic, so our guest can proceed first. We will give you the topic.
A quick note for all participants. The poster presentation will take place in the exhibit wing of ISTAR on the top floor. Kindly arrive there on time at 2 p.m. and stand at your assigned poster sequence number. Thank you for your